Hi, everybody. Please take a second to read the warm-up question posted here. Pause your video and then resume when you've got an answer. All right, presumably you're ready to go. Here's what I said about it. That is a very leading question. It's way easier to say yes to that question than it is to say no. And also, you may not have gotten this one. The student's just approaching the people they happen to encounter. We don't know if that's going to be representative of the entire school or not. It might not be, depending on where they were standing and who they happened to approach and who they felt comfortable talking to. That's kind of the focus of our lesson for today, is this idea of who you're actually approaching with your sample question. So first, some definitions. If you've collected the data from every single person in a population, that's called a census. If you survey every single student at Terra Linda, you've done a census. The U.S. government does a census of the entire U.S. population every 10 years. We're in one right now, and it is the single biggest peacetime operation our government does. It's colossally difficult and colossally expensive. So very often we don't do a census, we do a sample. We collect data from only a small part of the population so we can estimate the whole. It's a lot faster, it's a lot cheaper. Sometimes it can even be more accurate. In particular, if a census takes so long to do that by the time you're done with it, the question you're asking is moot, doesn't matter anymore because it took so long to get an answer, then a census is pretty useless and a sample is about all you've got. Ideally, we want to do what's called a random sample. In a random sample, every single member of the population has at least some chance of being selected. In an ideal world, every member has the same chance of being selected, or at least the same chance as other members with similar characteristics. For example, every sophomore might have the same chance of being selected as every other sophomore. And then there's a non-random sample where some members have no chance of being selected. Those we want to avoid. Let's talk about the types of non-random samples that we're trying to avoid. A convenient sample is where you only talk to the most accessible members of a population, like our warm-up example where you're just talking to the students in the hallway, or like what many of you did for Project One, where you may have posted a survey to your Instagram story, and your sample was the people who happened to read your Instagram. Very convenient, not representative of students as a whole. A judgment sample is where you think real hard and use your judgment to try to put together a group that is representative of the population, but it's still not random. And a quota sample is where you say, okay, at Terra Linda High School, we have 30% freshmen, 25% sophomores, 25% juniors, 20% seniors. I want a sample of 100 people. I'm going to make darn sure I have 30 freshmen, 25 sophomores, 25 juniors, and 20 seniors. But I'm still going to do it by approaching my friends or by posting it to Instagram or whatever. So you're equalizing one criteria you've decided on, but you're still using convenient or judgment basis to collect the people. Fun anecdote about that. This used to be considered a perfectly valid sampling technique until we elected President Dewey. Remember President Dewey? No, you don't, because we never elected President Dewey. Everyone thought we were going to elect President Dewey because all of the polls said we were, because the polls were based on quota samples back in the 1940s. In 1948, we in fact elected President Truman, hence the famous newspaper of Truman holding up the Dewey defeats Truman newspaper page when, of course, Truman won. The polls were wrong. They used to use quota samples before that. After 1948, they had to stop doing that because they realized they were garbage. So, which non-random sample is each of these? Take a second, pause the video, write your answers down, resume when you're ready. That would be a convenient sample, a quota sample, and a judgment sample. If you need any explanation of why, let me know. Judgment sample in the last, that's your judgment. You're saying that, but you don't necessarily know that it's true. All right, so if those are what you want to not do, what are the things you want to do? These are the types of random samples that are valid. A simple random sample. If you have some master list of every single member of a population, you can just randomly choose people off of it. That's called a simple random sample. That's great if you happen to have that master list, which very frequently you do not. If everyone's sort of lined up in a row, maybe they're all walking through a door on their way into something or something like that, you can do a systematic random sample. You start with a random person, maybe a random person from the first 50, and then you choose every 50th member after that. This is particularly great if you don't know how many people are going to walk by. You don't need to know for this one. You just pick every 50th person for as many people as go by. Stratified and cluster samples are similar because they both involve dividing the population into groups. In a stratified random sample, those groups are called strata, and they're groups that are different in some important way, such that we need to make sure we sample each one of them. For example, freshmen, sophomores, juniors, and seniors at Terra Linda High School, or students who attend Terra Linda and San Rafael and Madrone, if we were looking at the entire San Rafael High School population. In a cluster sample, these are usually geographic, and here we're saying, look, these groups aren't fundamentally different. We don't need to hit every single one of them, so we're going to pick a few of these geographic clusters and concentrate our resources there. It's often done with geography because if you wanted to sample, say, the entire state of California, you have to send people out to certain areas to meet people. Well, if you divide California into geographic clusters, say zip codes, then that limits the number of physical locations you have to send people to, and that's going to save you a lot of money. So cluster, you have to make sure you hit every single, stratified, you have to make sure you hit every single strata because they're fundamentally different in some important way. Cluster, you need to hit a subset of the groups. You don't need to hit every group, you just need to hit some of them to give you a good picture of the entire population. Pause the video, take a second, write down your answers for each of these. Resume when ready. First one would be stratified. We're dividing the school into grade level strata. The second would be cluster. We're dividing it into geographic clusters of fifth period tutorials, but not hitting every single one of them. That's going to be simple, doesn't get any simpler than that. And the last one is going to be systematic. That list in alphabetical order might be a yearbook, for example. All right, so once you're done with this, what sorts of error can you expect? You're never going to get a perfect answer. You are always going to get something called sampling error. Because you're doing a sample, not surveying the entire population, you will almost never get exactly the same answer as you would have gotten if you had done a census, or even necessarily the same answer as you got from another similar sample. This is called sampling error. It's unavoidable. It's not a problem. It is important that we quantify or estimate the amount of sampling error. We're going to talk about that in May. Non-sampling error is what we're worried about. Non-sampling error is errors that occur in collection or recording of data that can skew results. These are what we want to focus on avoiding. Every time you design a sample, you need to think about the ways non-sampling error can occur and try to build in mechanisms to reduce them as much as possible. Here's our non-sampling error. Selection error. Let's say you want to sample the population of San Rafael. Now, there is no such thing as a master list of everyone who lives in San Rafael, but there are things like that. For example, a phone book. So you take a phone book and you randomly choose people out of the phone book. Well, the problem is, what about people who don't have landlines, who tend to be lower income, younger, etc.? Well, now you've just biased your sample in favor of people who happen to have numbers listed in the phone book. That's called selection error, where the list you're choosing from is not a true picture of the entire population. It's only a picture of a subset of the population. Non-response error occurs when people do not respond to your survey. You call them, they don't answer the phone, you never call back. Well, maybe the sort of people who didn't answer the phone are the people who work during the day, and that makes them fundamentally different from the people who are at home during the day answering the phone. Now you've suddenly biased your answer in favor of people who are at home during the day, who are older, who have shift work, things like that. Response errors when people give inaccurate responses. Call up people, ask them on a scale of 0 to 10, with 0 being terrible, 10 being excellent, and 5 being average, how good of a driver are you? In theory, you average responses together, you should get a 5. You won't, because all of us think we're better drivers than average. You'll get an average of like 7 or 8. That's response error. You're asking people a question they cannot actually give you an accurate answer to. Voluntary response error is kind of a different bag of worms. Voluntary response error would be, instead of approaching students at TL, you have something read over the bulletin and you invite students to volunteer to respond, or you post something in the IJ with a link asking people to volunteer to respond, or you stand in Northgate Mall with a table asking people to approach you. The sort of people who voluntarily step up to respond to a survey are probably not representative of the entire population. What type of error will each of these have? Pause the video, write down your answers, resume when ready. There you go. Top one, both selection error, because they're not looking at the entire school, just the people who happen to be in that hallway, and response error based on how they frame the question, etc. Bottom one will have non-response error. People often are going to ignore that email, and the sort of people who ignore that email are not necessarily the same as the sort of people who respond to it. All right, putting that all together, if you wanted to design a sample of illegal landlords in San Francisco, these are people who by definition are breaking the rules and probably don't want to answer a survey to out themselves. So how might you survey illegal landlords to find out why they're not legalizing their apartment? Here would be my answer for that. I'd use tax records, which are a complete record of the owners of every single family house in San Francisco. That's a big area. I would use clusters. San Francisco has 27 zip codes. That's 27 clusters. I'll randomly pick 9. There, I've just reduced the amount of work I have to do by 2/3. Within each cluster, I'm going to do a systematic random sample. The tax records give me people's houses in some sort of a list. I'm going to use that list, hit every 20th house down the line, starting with a randomly selected house from 1 to 20. That way, regardless of how long the cluster is, I'll get 1/20th of each cluster. Now I'm looking at owners so far, not landlords and not illegal landlords. I recognize that. So the first thing I'm going to do is send them a mailer with a link to an online questionnaire. By going online, it becomes anonymous. I'm hoping to reduce response error by that. I'll ask them first if their home includes a rental unit. I'll ask them whether or not the rental unit is registered with the city. And now I've got my sample of people who respond that they do have a rental unit and it's not registered. Now I've got my sample of illegal landlords and I can ask them all the questions I've got. I'm trying to avoid selection error by using tax records. I'm trying to avoid non-response error. I'll give it out in multiple languages. I will make clear that it's anonymous. I'm trying to reduce response error with the anonymity aspect of that. And this really should go in this category. I should update this slideshow. A common way to avoid non-response error is give people money or the opportunity to win money, which seems to work just as well. I'll enter every respondent in an opportunity to win a $100 gift card. I only need to give away one gift card, but the number of people who will respond goes up dramatically if they think they can win something. If you want to try this yourself, pick one of the populations on the next slide, design your sample, email it to Mr. Agnew, and I will give you some feedback on it. Best of luck. Pause it here, pick one if you want to go. Otherwise, good luck on the assessment.